Hey team, in this video I'm going to show you how to calculate the pH of a weak base using kind of technique that you will have to use in NCEA level 3. Just note there are other ways to do this, but I think this is the way that works best at this level. So the question is to calculate the pH of a certain concentration of NH3. You're given a Ka value. Note that the Ka value is for the conjugate acid for the base in the question. So that means we can use this value to calculate the Kb. That's where I'm going to start actually. So I'm going to go Ka times Kb equals Kw, which is 1 times 10 to the minus 14. So therefore the Kb is going to be 1 times 10 to the negative 14 over the Ka, which is 5.6 times 10 to the negative 10. And I'm just going to do that on my calculator. 5.6 times 10 to the negative 10. So that gives me 1.79 times 10 to the minus 5. Right, so I've got my Kb now for the NH3. So then I'm going to take my base and I'm going to write a base dissociation equation, just like we do for the acid. This is weak, so it's going to be an equilibrium. And you'll notice that you get the conjugate acid in this equation as well. This is going to become quite important when we look at a later section called buffers. Okay, so now I'm going to write a Kb expression. So just the same process as we used for the acid. Just looks a little bit different. So instead of H3O plus, we have OH minus. But we are going to be able to make the same approximations, or the same assumptions as we did for the acid. So my next job is to sub everything in. So I've got my Kb up here, so I'm going to put this in here. I'm going to make the same assumption that these two are in a 1-to-1 mole ratio, so I'm going to call them X, and so that's going to be X and X. And the second assumption, which is the same, is that because this is a weak base, I'm going to assume that it's just about 0 dissociated. So this concentration here is essentially the concentration of the base itself. So I'm going to put that down here. Right, so the next job is just to solve for X. So I'm going to make that X squared, and I'm going to rearrange to give me X squared equals 1.79 times 10 to the minus 5 times 0.0527. And that gives me, I'm actually using the unrounded value, 0.0527. So that gives me 9.41 times 10 to the minus 7. And then to get X, I'm going to square root that number there. And that gives me 9.70 times 10 to the minus 4. Now that is X. Now in this case, so this is the other difference to the acid calculation. These are my X's, so I've now got OH minus. Right, not H3O plus, so I can't just negative log this. So what I'm going to do is I'm going to negative log it, but I'm going to recognize that that is the POH. So negative log of the OH equals the POH. So I'm going to negative log this. Right, and so the negative log of that equals 3.01. Now, even if I made a mistake, I should look up and go, okay, that can't be the pH because it's a base. So the other relationship that I now need is that the pH plus the POH equals 14. You might not have used this method before. I highly recommend it. It's a lot easier than the other one. So now I've just got to go 14 minus 3.013 and minus answer equals, that equals 10.986, which to 3 significant figures is going to be 11.0. And that is my answer.